Now we're going to look at a way that we can use quartiles to quantify unusual data in terms of a value called the interquartile range, or IQR, where the interquartile range is just a representation of where most of the data lies. It's the range of values between Q1 and Q3. It's that middle 50%. And for us, the most useful thing we have about the IQR is how we can talk about outliers in terms of it, where you think of an outlier in general as an unusually large or small value, a value that doesn't fit the rest of the data set. And here, we define that in terms of the IQR by saying it is a value that is 1.5 times the IQR away from the ends of it. So actually, let me just draw a quick picture here to help illustrate the idea. So let's say we have our data set, and it's something like before. So we're going to have our value for Q1 down there, and our value for Q3 is over here, and Q2 is somewhere in the middle. This range here is the interquartile range that we're talking about in this context. And what we do to find an outlier is we take 1.5 times this value. So we take this and go a little bit wider out. We subtract it from Q1 to go a little bit further over here, add it to Q3 to get a little bit further over there. So that if we get some value that's way out here, that's well outside that, that's more than 1.5 times the IQR above Q3 or somewhere over there, but I don't want to draw on my wall, we can say that it is an outlier based on its position relative to the data set. And to understand this, we're going to go back to an older example. So from back in 2.3, when we talked about that stuff with the zoo, illustrating measures of central tendency, we had that unusual height that corresponded to a giraffe. We had that height of 168 inches in our data set of what was supposed to be third graders. And here, if we go back to the zoo data, so for that data set, we would have that Q1 is equal to 44, and Q3 is equal to 51.5. And I'll leave this to you to verify that that's the case. It's not that complicated though. But once we have our values here for our quartiles, what we can do is find the IQR, where the interquartile range is just going to be the high end minus the low end, so 7.5, which means that if we want 1.5 times that interquartile range, we're getting that plus a half, which I want to be careful about getting that number just right. But here, that would be 11 and a quarter, specifically 11 and a quarter inches. So if we want to quantify an outlier, what we do is we take that value, we subtract it from Q1, and we add it to Q3. And we don't need to do it for the Q1, but I'll do it anyway just to clarify. So on the low end, for an outlier, what we do is we take Q1 minus 1.5 times the IQR, which in this case is 44 minus 11.25, or what we would end up with here is 32.75 inches. And hopefully you can guess that would be a very unusual height for a third grader. It would be a very unusual height for really anything but a toddler, because that's less than 3 feet tall. It's quite short. On the other hand, for the top end, for the high end, we have Q3 plus 1.5 times the IQR, which would end up being 51.5 plus 11.25. Where if you take 51.5 plus 11.25, you'll end up getting 62.75 0.75, so about 5'3". That's pretty tall for a third grader, but I guess not impossibly. But importantly for us, this is still significantly less than 168. So our suspicions from earlier that 168 is an unusual value, as it well should be, it's a giraffe's height, is quantifiably unusual. That is, 168 is an outlier. And the next thing we're going to talk about is kind of pulling this stuff together with a nice pictographical representation, because this is a lot of number chasing we have so far, and we like our numbers to look a little bit cleaner and be able to sell our stuff a bit clearer when we're talking about these things. And we'll see that with a construction called a box and whisker or box plot next.